Hello. Hello.
Hey, no,
Okay, so good evening. How are you?
I'm doing good. Thanks a lot.
Okay, so first of all, I will try to discuss about your solution or your problem. So previous code, I also tried to check this code. In this code, I also find out some problem. This problem is that you can take the training point for you did not maintain the sequentially. Suppose you take the training point for the 40 or 83 for the build up area, then you can get the directly 400 training point for the barren land or other training point look like this. So in this time, when you want to take the training point, you need to take the training point as a similar. Okay, suppose you take the 40 build up area 40, barren land 40, or similar or almost similar. Okay, so in this time, you also take the training point from the other side outside of the satellite images. So it's also created the another problem. Okay, so you need to take the satellite images training point only for the satellite images, then it will be work properly. Okay, so I hope you also reduce this training point also. Yeah, did you reduce this training point?
Okay. I yeah, I will. I try to do is this, but I still have a problem also because I see the result. It gives me build up in the Berland. It means it have a
So
same
it's the
spectral
mixing
values.
mixing the build up and barren land, this type of problem you can face.
Yeah, I will change all this training, and I will make a new training site again. Uh, but also there is a problem. I don't know if it is a problem or not. If you see the screenshot, it
Okay, so
was
if you want, you can simply share your screen, then I also try to check.
okay because okay. I let me see exactly the code. Wait. Yeah.
Yeah.
Um, just loading. Okay. Okay. The question is the result of the band sharpen image. If you see what I gave, what I asked you last time, if you remember that we had this result, the RGB red, green, blue, and I don't know if it is correct or not.
So in this code, do you have also selected some other types of band, such as in this time we are at the band for the some external band such as already available in the satellite image, such as blue, red, green, B1, B2, B3, B4, B5. All of the band is already available. So I think you are also applying in this code for the pen sharpening technique and reduce this image resolution.
Yes,
Okay, okay, I understand.
exactly.
Yeah, 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 yeah.
But I don't know if it is correct or not because it gives me a new result, and it's supposed that we have, for example, the red, green, blue, the same bands, but the resolution became higher. But in this case, I see a new band is added because we have two red and two blue and
Yeah.
two green, if you see. And this is, I don't know if it's correct or not because it's weird. They never, it's always have one band for each one.
Yeah.
Yes, this is the question that I don't know if it's correct or not.
Okay, if possible, you can also send me the code link. I also try to open this code in my system.
Okay. Okay, perfect. No problem.
Try to check.
Okay. I will send you the link after
I
the
think
call
some
and
networking issue.
yeah, it is slow. I don't know why. But even, I have a small study area, but it always gave me a problem that he cannot calculate the pixels. He say it is over 1 million pixels. Even it is a small study area.
Okay, so in this time, the first time I also check the code when you want to take the lot of training point for each classes. So that's why
Hmm.
it across the limit of 5,000 element. Okay,
Okay.
so now I hope when you want to reduce this training point of all classes, then I hope we can easily get the solution of this problem. And mainly when it will be across
Okay.
the limit 5,000 element of pixel value, then we can get the message look like this. It across the over the
Okay.
5,000 element.
Okay. Perfect. So I will do it today. I will send you the link after we finish.
Uh, uh, did you send me this link?
Yep. Just a second. I try to do it just slow today a little bit. I will send it right away.
I think some networking issue also.
Yeah. I sent it already. Yeah. Okay. I already make some tests over some stuff, not for land surface temperature and bench shortening, and I'm still waiting just to finish all these codes. I still have many problems in each code, and I will try to send you all the stuff, all the question organized a little bit more.
Okay.
Yeah, that's it. Did you get the code by mail?
So you can send me this email, yeah?
Yeah, I sent it to you. Yeah.
Okay, I get it. Okay, can you see my screen now?
Yes.
Okay, so
So we have here like 21 band. Yeah, this is the first object.
okay, you can see it's showing the message collection query aborted after the accumulate over the 5,000 elements. So in this time we also need to reduce this image collection. Here you can see you can take the build up area 322, 401. So it
Mhm.
carries the lot of pixel value. Okay, and in this time you can see I think the red color is showing only for the build up area and yellow color showing the barren land. Okay, so in this time we can take the training point, large number of training point for the build up area and barren land. So that's why in this image all of the things will be showing only for the build up area and barren land. But when you want to get the training point is as a equally distribution, then you can get the
Mhm.
all of the feature you can easily find out. Okay, so mainly in this
Okay, so
yeah.
you suggest if we work, for example, with provinces, we make a separate classification for each province
Yeah,
to cover a specific.
yeah.
Okay,
So in this time you can see, suppose
sounds
this
good.
classification is the okay. This result is okay only for the build up area and barren land is the okay. But you also need to classify it also cropland water. Okay, so you can see cropland water very mass or very little. Okay, so that's why in this time we need to take the training point is the equally distribution. Then we can get the result proper result, and it also not across the our limit 5,000 element. Okay, so in this time I can simply remove the some. Also you can see you can take the training point from the outside of this satellite images. Okay, so my boundary area is only for this area. Your only for this image you need to training point only for this satellite images, not outside of this area. Okay, so in this time I simply remove some training point. So you can simply click on the delete, then it will be easily removing. So it takes a lot of training point, so a lot of training point is not need. But when you want to classify it and check the classes is not available, you need to classify the build up area, but you can also see this is the water body. Then you can also take the training point instead of the water body or build up area. Okay, so first time we don't need to use the lot of training point. And when you can see your accuracy is not good, then you can also increasing the training point. Otherwise it's not need. My god, we need to take training point only for the satellite image. So now I can get the only for the 42. And I ran the code and check what the problem. And then I also decrease the value of the cropland, also barren land. So just a minute.
your information today.
Okay, so just I simply reduce the build up here training point. I can get the 42 point and then try to run the code and check what's the difference I can get. Then I also reduce the cropland training point, also reduce the barren land training point.
Okay.
Okay,
And
yeah.
yeah. See, this is the problem that you see, but about the, if you go down, you see, for example, I will tell you which line exactly. Yes, the line 80, for example, the line number 80,
Yeah.
you will see like some bands. I don't know if it's correct or not.
Okay, so basically this is the band for cloud marks band. So mainly, okay, so I also not discuss about this cloud marks band function because we directly jump on the land cover classification class. So in this time, basically you can see this is the code for removing the cloud and haze from the satellite images. Okay, so it's very easy. You can see BQA. So this is the band. This is the band for cloud marks band on Landsat 8 images. Okay, so then I just simply take a variable. This is my function variable name. I can put the function keyword. I put the element name is the image. Then use the curly bracket. In this curly bracket, I put my argument, what I need. First of all, I simply select the BQA, this band. Then I simply select the bit 4. What is the bit 4? Bit 4 is the cloud or cloud shadow. If you want to check the information, you can simply search the image on the, you can simply, okay, just a minute. So I simply go to this image information sheet. I simply copy and paste in the data set. Then I simply get all of the information from here. So I simply click on the band. So here you can see. Okay. So you can see what is the bit 4. Bit 4 is the cloud. Okay. So I want to remove the cloud. And bit 4 has a 2 signal. 0 and 1. 0 is the no cloud. 1 is the present cloud or yes. So I need to select the bit 4 equal to 0. Okay. So that's why I simply put it at the code. You can see bit equal to 0. Then update this marks and this is my function variable name. This function variable name I just add with my image collection. My image collection you can see composite. I simply use here the map function and call the function variable name. So now this all of the cloud marks band function added with my code and now remove all of the cloud and haze from my satellite images. Okay. Okay, I think some networking issue. So internal error has occurred. Request. Okay. So this is the code for removing the cloud. And also you can see we can add the another function pen sharpening. So mainly we are using the pen sharpening for reduce for get the high resolution satellite images. So basically this is the 30 meter resolution. When you want to use the pen sharpening, we can get the 50 meter or 20 meter distance resolution of the Landsat 8 imagery. Okay, for we can easily get the all of the feature, all of the we can all of the things we can easily identify from the satellite images. Okay, and then you can see you can just clip with your shapefile. You can get the show the satellite images. You can see. So we can add the satellite images. Okay, and pen sharpening, pen sharp. Okay, so we can use this pen sharp. So you can see after pen sharpening, I can get this image. So pen sharp, I can get this image. And now this image resolution is the 50 meter. And now we can easily identify. But this is a Landsat image. Landsat image is basically 30 meter. I use the pen sharpening method for get the high resolution satellite imagery of the Landsat 8. Okay. After this, I also add the some indices. So in this time, here add the indices for the NDVI, NDBI, as well as also MNDWI, BSI. So this is the barren soil index. MNDWI, this is the water index. I think this is the build-up index and this is the vegetation index. So you can add all of the formula. Okay, normalized difference you can add, and this is the formula for the BSI or barren soil index. I can add this all of the formula. In this time, all of the basically this is the external band. Okay, not internal band. I can create some external band NDVI, NDBI, MNDWI, BSI. Create all of the external band. In this time, you can say I simply add bands. All of the things I want to add this band. This band I want to add as a prediction of pixel value. All of the point from the all of the point I get all of the band value. Suppose this point, what is the NDVI value? This point, what is the NDVI value? This point, what is the MNDWI value? This point, what is the BSI value? I want to get all of the pixel value. Okay. Then you can also calculation the SOLP and elevation also. So you can add the data set for the, so you can use here this, you already import the data set. Okay, so this data set you want to import. I also check the data set. So basically NASA SRTM data set we can also use, but this is the another SRTM data set. A DSM global 30 meter digital surface model or DSM dataset with the horizontal resolution approximately 30 meter. The dataset is the base the DSM dataset. Okay, world 3D topographic data. Okay, so arrival dataset domestic. Okay, and this dataset band is that, okay, so height above the sea level. Okay, this represented the height above the sea level and elevation in meter. Convert the from the, okay, so we can get the elevation dataset format. You can simply select the band name. Okay, so then you can just simply okay, so you can simply select this and rename it the elevation. Okay, also you can calculate it the SOLP using this data set. You calculated the SOLP. So this is the function train.solp. Then I can simply select this and rename it the SOLP. So basically we use the elevation model data or digital elevation model data for calculating the SOLP. And in the Google Earth Engine platform, this is the ready-made function or built-in function. When you want to calculate the SOLP, just you can simply put the function, then simply call the dataset name. You can simply call the dataset name, also select the band and also rename it as a SOLP. Okay, in this time you can also add this band, the elevation pixel value as well as also SOLP pixel value. You also add as a external band. Okay, so then you also try to add here this visualization of this. So okay, so you want to add the visualization. So I simply call this visualization and B4 B3 and I simply open this. So now we can check. Okay, so now we can get the result B4 B3 and B2 bands between these trains. Okay, and I also print this. What the result I can get from here, you can see total, we can get the total 1081 training point. And I also check this, so all of the training point I can find out in here. When I click any training point, I can get all of the result. You can see I can get this is a class 2 and this training point is at this location, but it's not added any types of training pixel value. Okay, so then you also add the merge all of the training point. You can see, so what are cropland, build up, as well as also barren land you can merge, and also you can add here the band. Okay, so in this time you can see you add all of the band. So this is my external band. Internal band is already available in my satellite images, and I also create some internal band. Okay, you can see blue, NDVI, MNDWI, BSI, elevation, and SOLP. So I also use this elevation, SOLP, all of the band I want to add. After this, I simply take the pixel value.
But
Yeah,
I'm just,
yeah,
this is, the question is here.
yeah.
The bands.
Yeah.
If you open in the console, you will find the list of bands.
What's band?
If you open the console in Google Earth Engine, in the first product, you will see, yeah, we have RGB 3214, and you have red, green, blue. I add this because the result, if you go just up a little bit in the console at right.
So basically, this is the visualization of the true color composite.
Yes. I know this. I made this code. I understand it. But the question is, if you go just at right on the console, at right, the result of the band sharpened image.
Yeah.
Yes, we have a result here. If you go up at right on the console.
And
Inspector. At right.
okay, so basically in this time when you want to make the pen sharpening method, we need to use here this total 4 band, B4, B3, B2 and B8, and also need to convert this RGB to SSV. Okay, and then we also need to add all of the things, and also then it reduce this image collection. Okay,
exactly. So, if you check this collection, you will find we have some bands RGB and red, green, blue. If
Yeah,
you just check the result. So I don't know if this is correct or not, because we have two red and two blue and two green.
yeah.
So I don't know.
So
This is
RGB. So mainly we can reduce this in this time. I want to get the satellite images true color composite. So true color composite, it's also called the RGB color. The RGB color is identified only for the B4, B3 and B2. And I want to pen sharp, I only apply the pen sharpening method on for the true color composite. So that's why we need to select the B4, B3 and B2 or red, green, blue or RGB color band. Okay.
okay. If you just open the console result on the at the right side, at your side, the console at right
Yeah.
inside. Yeah. If you go up, the first result. Yeah, 21 image. If you open the 21 image, the first one. Yeah, you see the bands. We have red, green, blue, 12, 13, 14.
Red,
But
green, blue.
Exactly. And we already have these bands on the top. If you go up, you will find the band 4, 3, 5. Yeah, yeah. You see?
Okay, so in this time, if you want, you can use this red, green, blue, and also you can remove this red, green, blue. No problem for this, because we are already used the B4, B3, B2, and B8. So B8, mainly B4, B3, and B2 for the red, green, and blue. We already use this for the pen sharpening method. Okay, and add all of the reduce this image resolution. Okay, so that's why in this time, if you want, you are using this red, green and blue. Okay, and this three band we can create after using the pen sharpening method. Okay, and this you can see B4, B3 and B2. This is the totally external band. So if you want, you can simply remove this and use the B4, B3 and B8. There is no problem. So okay, so you can see, so B4, so you can simply remove. Okay, because we already added, you can see, already added the red, green and red, green.
This is the question.
And what is the blue? Red, green and blue. Okay. Okay, blue is available, no problem. Then all of the bands from that. Then click to the run. So then it also, okay. So then we need to, okay, in this time we also need to in this time all of the band value I want to need for all of the training point. Okay, so all of the training point. So for this I simply use here the sample region function. So basically this is the sample regions. Also you can see we use here the 15, because we need to use basically Landsat is the 30 meter, but when you want to pen sharpening method, it turn into the 50 meter resolution. So that's why we are using here the 15. Okay, then this is our properties name. When you can get the training point, we are using here the class. Then this is our training, or it's stored all of the merging training point. You can see when I merge, it will be stored in this variable. So I simply use this and print this. So now it will be, so we can check, we can get the wrong, because we can get the lot of pixel value. So we also need to reduce this pixel value, then try to run this code. So I simply reduce the build up area. I also need to reduce some the cropland. So I simply reduce. Okay, so you can see you can get the training point for this region, but it's not neat because there is the no satellite image in here. So I simply remove.
Yes, but you know what? Before I was studying a larger area which cover all the training point. If you go
Okay.
up, you will sign. It was great. I call it great area. It's a variable. I identified it. So I already made all the points inside it, the training inside the image, but I still have the same result.
So you already reduced this training point.
Yeah.
Okay, so then
I
you can.
did.
Okay, so then you can simply send me the code. Then it also easier to. It also take shortage our time, and we can easily get the
Yeah,
result.
exactly. Okay.
You can send me this code. You can see it's showing the too many pixel in the ensure that you are not aggregating higher resolution that you intended. Okay, so you can see it's showing the too many pixel value, but because there's a lot of turning point. Okay, so that's why we did not get the result. We can get this type of error in here.
Okay. I will change that. Oh.
Okay, did you send me an email? Yeah. Did not get this.
It's okay. I will change this and I will send it to you tonight or tomorrow until I will remove all of these training points and I will
Okay, so
delete
it's
it.
also better. Yeah. You can remove all of the
Okay.
training point, and then you also take the training point from the satellite images, and also try to add the training points equally distribution. Then it also better. We can easily get the confusion matrix equally. We can easily get the accuracy assessment. We can easily get all of the
Okay.
things easily. Okay, and in this code I think is already is the done, but you can see we are using here the chart. Okay, so sometime the chart is not work, then we move to the
Mhm.
another method. Sometimes you can see this chart is not suppose when you want to work with the big region, this chart is not work, then we need to work with the another data another way. We can get the calculating the area for another way. So basically today's class I also try to show you this part, how you can easily handle the big area, calculating the area. Suppose you want to classify the area as a big region and you want to apply the chart method, it's already not work because there are a lot too many pixel value in the big region. So then we also need to apply the another method. This method is that, so you also try to remove all of the training point and then try to again take the training point. Okay, equally distribution, then you can try to run the code and then face any problem, then let me know, then we also try to discuss, no problem.
Okay.
So in this time we are just try to show you
I
that. Yeah.
Okay. I have only a question now. If I, for example, I study the land cover in Cairo, and I will make a study for last 15 years or 20 years. So I have to take training points for each 5 years or whatever. I have 5 year period. So because there is already a change in line cover, so I have to create a new code
Yeah,
for
so
each year.
yeah, you when you want to get the better accuracy, then you have to take the training point for each year.
Okay, it's
Okay,
better.
but you can also check the your suppose you take the training point for the 1 year and then try to apply the all of the year, then you can also check your accuracy is not good, it also reduce the accuracy.
Yes, yes, I see. Yes.
Okay,
Okay.
so I simply go to our today's class, then try to discuss about this part. So I
Okay.
simply open my code editor. Okay, so basically today's class I will try to discuss about this part. So how can easily calculating the classification area as a big region. Suppose when you want to work with the small region, it will be okay. There is no problem for making the chart and calculating the area. But when you want to use the suppose you want to suppose big region, such as a big country, you want to calculate the area, then you need to face the some problem. Okay, then you can easily use the accuracy assessment. Okay, then how to use the different classifier and check the accuracy result. Suppose you want to check the accuracy using the random forest, you can get the accuracy result. Suppose you want to use the another accuracy such as a classification and regression trees and check the accuracy, then create the confusion matrix, how to create one class map. Suppose you want to need only for the water area map, you want to need for the only for the build up area map. Suppose when you want to work with the urban expansion or urban spiral, then you need to also work with the build up area. So we can suppose sometime we also need for the water area map only, sometime we also need for the only for the build up area map. Okay, so these things I also try to discuss about this. So first of all, area calculation area. So mainly when you want to calculate the area, so suppose area on you can easily calculate the area for the vector, as well as you can also calculate area for the images. Suppose you want to add the land use land cover classification image, and now you want to calculate the area. Okay, so let's go. We also try to show you all of the method for calculating the area. Suppose you can see this is the code. Basically this is the classification map. We can get the data for the sentinel. Okay, sentinel dataset. Basically this dataset is the ready-made dataset, world dynamic world land cover dataset. Okay, I also try to discuss about the dataset, then try to show you that all of the process. Suppose you can see this is the dataset. So this is a dynamic world dataset. Okay, in this dataset we can use that the 10 meter resolution imagery. So all of the things we can get. Basically this dataset ability, it will start from this time period, and the present time we can get the dataset. And this dataset has some band such as you can see water, trees, grass, flooded vegetation, crops, surf and traps, and build up barren, snow and ice. Okay, and also you can see index of band with the highest estimated probability, and this is the index, so level. Also you can see level, this is our class name. In this class has the total, you can see water, trees, grass, flooded vegetation, crops, all of the things. Also provide some color. Okay, all of the color. So in this time I want to use this data set and try to calculate the area. So in this time, okay, so I simply change the geometry and try to add the big geometry. So I simply remove it, and then I simply add the geometry for suppose Bangladesh. So I just simply import the Bangladesh country boundary. Okay, Bangladesh simply import, and then try to simply copy the geometry. Okay, so in this time I simply import my geometry. This AY is not need because I want to use the geometry, and click to the run. So now I want to get the result. You can take for the whole country boundary of the land use land cover classification map for year of 2021, 2020. Okay, because this time period will be start from 2020 and 2021. This time period. So I will get that I add a layer. So I need the classification composite. So in this time I want to focus the center of the shapefile. Just a minute, I simply get the map dot center object, then call my geometry and use here the suppose 10 meter and click to the run. You can see I first of all I simply apply the code for the I apply the chart code. You can see this code is for the chart code. Okay, and this chart code I want to make the chart and try to calculate the area, but I did not get the area. It's showing there are a lot of too many pixel value because this is a large boundary. Okay, so there is a lot of pixel value. In this time when I want to make that chart and I want to calculate the area, it's not possible. Okay, because there is a lot of pixel value found. You can see the large number. Okay, but max pixel value allows only for this value, but it across the limit. Okay, so that in this time we are not applying this chart type calculation. Okay, so in this time you can see I want to get this land use land cover classification map, and I also need to calculate the all of the areas as how much water body, how much all of the classes which are available in this data set. You can see all of the data set: water, grass, trees, grass, flooded vegetation, crop, surf and crops, and yield of area brand. So all of the class I want to calculate it in this time. So for this, okay, so you can say I can get the result. So all of the things I want to get. So in this time I want to calculate the area. And exporting the same process when you want to export any types of map and work with the ArcMap software for making this type of map. So this exporting process is the same. Okay, So in this time, I want to work with this because the chart image is not work. Okay. So first of all, I try to show you that how you can easily calculate the geometry. Suppose you want to calculate the area for Bangladesh boundary. Okay, you want to calculate the area for Bangladesh boundary. So for this, you can simply work with this code. So I simply take a variable. Suppose this variable name is that, suppose geometry area. In the geometry area, I simply call the geometry and put here, paste here, geometry dot so in this time this is my variable name. Okay, and this is the geometry, so that's why I simply use here the geometry function again, geometry. Okay, then I simply use here the area function. Okay, this geometry is the default variable name. You can use any name, no problem, but when you want to calculate the area, you need to add here the also geometry. Okay, and then you define it, this is the area. So in this time I simply just print this. I simply use the print function and call the geometry and paste here and click to the run. So now you can check what the value we can get. Okay, yes, I can get the area. Okay, but this area is for meter square. Okay, meter square. But in this time I want to need the area for the suppose a square kilometer. Okay, so a square kilometer unit. So for this I just simply convert this unit. So I simply take a variable. Suppose this variable name is the geometry. Suppose a square kilometer. Okay, I simply put the variable name. In this time I simply call it. I just convert this number into a square kilometer. I simply copy and then I simply paste here. Okay, after this I simply use a function. It's called the I need to use it the e dot number. Okay, because you can see this is the number. Okay, and this number is stored in a variable. What's the variable name? Study area. I simply copy and paste here. In this time this number I want to just convert into a square kilometer. So just I simply divide with 1 million or 1 into 10 to the power 6 or 1 is 6. Okay, this value. In this time I simply print and then geometry square kilometer I simply copy and paste here and then I simply click to the run. So now you can say I can get the result square kilometer, the whole area. So it's almost 1,39,976 square kilometer, the whole area of Bangladesh. So in this time I want to also calculate it. You can say it is showing the also floating value. Suppose you want to read only for the integer value, you can simply use a function. It's called the round. I can simply use the round and click to the run. So now I can get the round value of this figure. You can see I can get the round value. So this is the process. This is the process. Just a minute. I simply important message. Just